Thanks, Chris. Hello, my name is Craig Barr, and today's webinar is going to be focusing on design manufacturing for real-time visualization utilizing Unreal Engine. We're going to be taking a look at how we can visualize, whether it's engineering data, perhaps it's architectural data, but specifically in this case, we're going to look at this awesome bike design by Rizoma Bikes. So without further ado, let's get started. Unreal Engine is a powerful interactive visualization tool. At Unreal, we know the challenges faced by designers, engineers, and artists when it comes to CAD visualization. We've listened and we've been busy creating tools to make the design visualization process easier, more intuitive, and super efficient, saving valuable time and money. So let's take a look at a bit of the agenda for today's discussion. We'll do an overview of Unreal Engine and how it relates to CAD data, or for that matter, support of CAD data. And we're going to take a look at some foundations. Once we get this CAD data into Unreal Engine, now what? What do we do with it? How do we work with it? So we're not going to go really in depth in here, but what we're going to do is we're going to take a look at how we get that CAD data in, and then how we can start to work with it to start to real-time visualize with that product design or that data. We're going to take a look at Unreal as an interactive environment for interactive visualization and all of the abilities or capabilities that it can bring with it as an advantage for a CAD or product design visualization tool. So I want to give a little shout out over here to the fine folks over at Rizoma. We're specifically using data that they've provided to us, their awesome design. I mean, this design is very sleek. Very impressive bicycle. This is the R77 Metropolitan bike. So as they like to say, this is featuring unique style and pure lines, and it is elegant and refined minimalism. So you can go on over to their website there, rizomametropolitanbike.com, and take a look at the awesome product offering that they have there. So before we start, let's take a look to answer this question of why Unreal Engine for CAD visualization. Well, Unreal Engine has this amazing ability to provide real-time rendering, incredible results, and the ability to not just provide just imagery or video, but this interactive environment, the ability to interact with data, utilize data, and work with data. Let's take a look at a traditional CAD workflow before we started to get into these different plugins or solutions for CAD designers. So traditional CAD to Unreal Engine workflow really quickly. You would design your CAD data somewhere in a CAD design package. You would work with exporting that in perhaps a format that might work for a 3D content creation package. In here, in the 3D content creation package, often traditionally, the data might come in a little bit skewed or something might be off. We may need to clean that data up. And of course, we need to think of things like UV layout, that is for texture coordinates. But we need UVs for more than just texture coordinates. We need it also for light maps and things like that as well, for baking lights within a real-time environment like Unreal Engine. So then we get into organizing the scene. Perhaps we've lost hierarchies or any of our scene assemblies that we need to rebuild. Now we may need to convert the data. This is where we get into this process of tessellating geometry, right? So we want to get this so that it works in a polygonal or a triangulated version for that matter over into Unreal Engine, something that the engine can work with. After we've tessellated it, once again, here we are exporting that data, and then we get into importing the data into the engine where we may have to reorganize this again and rebuild the scene essentially to be able to get this into Unreal Engine. Now that's the traditional CAD to Unreal Engine workflow. What we want to do is revolutionize or change this to be something a little bit more like this. There we go. CAD, Unreal Engine. And this is essentially what the process should be. Taking the pain out, taking the time out of this. We want to make this as efficient and effective as possible. So this is where we get into this conversation of data translation. So there are some challenges that we face traditionally when we're taking CAD data created in a CAD package and bringing it over into a real-time interactive environment like Unreal Engine. So if you're doing this by hand, you're often battling with preserving the overall accuracy, right? You want to keep everything accurate to the original CAD designs, but it needs to be efficient. It needs to work real-time. It needs to be able to allow you to interact with it and visualize it in whatever way you want to visualize that. So we need to keep that mesh fidelity while keeping the overall scene and geometry light. That's a challenge. Often we're taking huge data sets and trying to make sure that we maintain the accuracy while keeping the overall geometry load down to be able to work with it in a real-time environment. Of course, we need the basics. We need to maintain scale, the overall proportion, and the volume of the data that's coming from the CAD package. And of course, we are also faced with the loss of data. We may lose things like previous texture coordinates that are important for maybe logos or anything else to be able to hold that texture coordinate on there. So of course we get into the world of Unreal and UVs. Well, the basics of Unreal when it comes to texture coordinates, or UVs for that matter, is that UVs are needed for two things. For textures, for those things like logos or perhaps as a leather texture or something that carries across a surface. But in Unreal, for a real-time environment, we also need them for something that we call light maps. And light maps is this place that we store lighting data in essentially almost like an image format where we can bake it down, and this way the lighting is allows us to carry this forward as a very light and efficient method to be able to visualize data without having to have the overhead of the complex calculation of real-time lighting. We can use real-time lighting, of course, within Unreal Engine, but if we have a massive scene with lots of complex, large data sets, we often want to take advantage of things, of Unreal Engine's powerful light map or light mask system, which will make everything run beautifully, lighting looking incredible, but very efficient, and allow us for that real-time interactivity. So we need UVs on everything, really, on every face of the mesh, not just for texture data, but for that light maps if we want to take care of the light mask system within Unreal Engine. So this is where we get to, we looked at that traditional workflow or that traditional pain points where we need to step through things. What about Datasmith here? What is Datasmith? Well, in brief, we'll come back to Datasmith. We're going to look at Datasmith as it exists as a plugin here in a moment. But here it is really in brief. Datasmith provides the accurate translation of CAD data. And this allows you to bring CAD data into Unreal Engine, a very efficient and powerful method of carrying that data from your CAD package right into Unreal Engine and taking care of everything behind the scenes for you so that you can focus on the visualization rather than the cleaning and fixing of data. So this allows you to experience your CAD designs, whether it's for an interactive visualization or perhaps some imagery or video, which you can of course create in Unreal Engine, or maybe you're creating something more complex. Maybe it's a virtual reality or an augmented reality interactive experience around your CAD data. And of course, you can port this into something like a mobile application as well. So Datasmith as a direct import. Now this is recent over the last little while in our implementation of Datasmith as a CAD solution for real-time visualization here in Unreal Engine. We have the ability to directly import this now into Unreal Engine. Now there's quite a few products that are being supported. I'm just going to name a few of them here. Of course we have things like SolidWorks, CATIA. You see products like Rhino. You can see that we have quite a few products here that we're able to take that data and work with this directly into Unreal Engine. Now, I should point out that Datasmith has been in beta for some time now, so we've been constantly working with these different file formats and many more than what I'm listing here so that we can preserve that accuracy or be able to make it simple for you to bring your designs into Unreal Engine and be able to begin to work with them in real-time visualization in an interactive environment like Unreal Engine provides for us. So let's take a look at the Datasmith plugins as they exist. So I'm just going to hop over here into 3ds Max, and I'm going to tell you why here in a moment. Now, traditionally, in the beginning of our talk here, we looked at this idea of traditional CAD workflows where we might have CAD designs and we might want that the beauty and the power that Unreal Engine brings to real-time visualization or visualization in any way, shape, or form for that matter. Now the traditional way is that we would often want to take that data and bring it into a 3D content creation tool such as Autodesk 3ds Max. Now a little bit more on 3ds Max here in a moment. I'll tell you why 3ds Max is a really good example for this here. But the traditional workflow, as I pointed out a lot of those pain points, we'd come in and we'd utilize the powerful tool set within 3ds Max or another 3D content creation package and be able to clean up that data, maybe reorganize it, fix some things, apply some UVs, whatever it may be. A little brief history here of Datasmith. When Datasmith was being built as a plugin, the first iteration of this was to implement this outside in a 3D content creation package. And the package that was chosen there was Autodesk 3ds Max. Now the reason for that There's lots of great 3D content creation packages out there. If you're familiar with those, whether it's Cinema 4D or Blender or maybe it's Autodesk Maya or whatever it may be, 3ds Max was chosen because Max has this amazing ability that it seems to blend and transcend into all these different industries, whether it is architecture or engineering or media and entertainment. Max seems to have this nice support for all these different worlds when it comes to different file formats. So if you're familiar with 3ds Max, you know that quite natively, a lot of the different CAD packages, a lot of that CAD data, those file formats, come in quite cleanly and quite easily and quickly into 3ds Max. Of course, we know the challenges when we bring data from elsewhere into another package. It's never perfect. We need to usually work with some of that data. Of course, things are getting better. But typically what we've done here, and in a little bit of the history here, is with Datasmith, the first package that we built this plugin, this Datasmith as a plugin, as an iteration here, was in 3ds Max. And that was because it had this ability to talk with these other packages. So it was a really good starting point for us to work with that plugin. And we could bring in CAD data, much like this bike that we're seeing here, and all of its different components and pieces that we can work with. And we could work with all of the different tool sets in here. If we needed to fix something, we could use the powerful 3ds Max modeling tools. If we needed to lay out some UVs, we could take advantage of that in here. So essentially in that way, Max was kind of working as this in-between, or this communicator for us between the CAD world of all those different packages, and there's so many out there, and Unreal Engine. And Max works excellent for this. So of course there's full support here for Max via the Datasmith plugin. And the way this works is that we would simply just select a component of our CAD data here, for example, or we could select the entire scene. For that matter, I could do that here. I'm just going to show where it exists in here because I'm running the plugin. And I'd go to Export, and I could come down into Save as Type. And this is where I might get into the Unreal Datasmith or .u Datasmith file format, where I could click that and begin to write out all of this data. Now it's going to send that out and write this out into its own Datasmith format. Now what would happen, let's jump in over to Unreal Engine here for a moment. I'm just going to jump into Unreal Engine, and here we can see I already have the raw data in here because we're going to work with this, and I'll explain why I have this data sitting here waiting for us here in a moment. Now I have these plugins installed here because I'm working with Datasmith. You can see that I have my little plugin up above here, Import Datasmith. If I check the little box here, you can see that I have an Import Datasmith and I have Import CAD. So Import Datasmith would allow me to take what I would have just done with something like 3ds Max, taking those Datasmith files that live somewhere else, and then be able to import those Datasmith files directly into Unreal Engine. Of course, now we've added this ability to support Datasmith in another flavor, and that is to import CAD data directly into Unreal Engine. And that's exactly what I've done here. So I want to show you, I just clicked that Import CAD, and if we go into our data set here, you'll see all the different file support that we have. Remember, I listed out all these different packages. You can see there's even more in here that we have all these different types of file formats. And this is where we can take a component here. Perhaps it's something designed in whatever package it may be, and we can bring that right into Unreal Engine. And this is exactly what I've done here. I'm working with data that I've brought over from another CAD package, and I have it nicely organized here. You can see that hierarchies are maintained and respected, and I can bring them right in here. Now, just to be transparent here, I do already have a couple little materials on here just for the sake of time. Also for the sake of time, importing the CAD data is a lot quicker using Datasmith than any traditional way. And what I mean by that is if we were to take this data and go through the traditional steps, as I pointed out, those kind of pain points of jumping through from a CAD package into something like Max or wherever else to do all the cleaning and the exporting, the tessellating, that could take some time, and then the exporting again and then bringing that over here. With using the Datasmith plugin or to import CAD data directly into here, I'm able to take advantage of Unreal Engine Live and be able to bring that data directly into Unreal Engine and begin to work with it. And you know, this actually didn't take that long. We have quite a few components here, several hundred pieces. Unreal Engine or Datasmith, for that example, can handle tens of thousands or even hundreds of thousands. It can handle an enormous amount of data to be able to bring live into Unreal Engine. And that's exactly what I've done. I've imported this data, and now what I can do is begin to work with this data. So if we wanted to start to work with this data, well, what is it that we want to do? How do we work with our data here in Unreal Engine? Now, I'm not going to dive too deep into here to get into some of the complexities of things, but I am going to dive into, what you would essentially do once you're in Unreal Engine with your data. So the basics are this. We've imported our data, and the important thing to note is that everything is maintained. All the position of our objects are maintained. The scale, the proportion, the volume, everything is as it should be, as it was designed in the CAD package. So we can see that the seat is where it should be. This crank assembly is how it should be. We can see that the drive belt, everything is lined up as it was designed and as it should be when we bring it over. We can also see that the quality of the data is very nice too. We're getting a real nice high fidelity preservation of everything, and we're able to bring this over into Unreal Engine. Let's take a look at what we have here with these hierarchies. You can see over on my World Outliner, I have all the different parts by their coded name, all the different scene assemblies into this nice simple little hierarchy here where we're able to work with things as they were. So of course I can turn off things like brakes, I can turn off the specific crank set, I can work with the drive belt individually. I can isolate the frame if I needed to. I can also see things like the logos as specific geometry as they were designed in that CAD package as well. Everything is divided into its separate little hierarchy here so that I have the ability to work with it separately here. You can also see, of course, the wheel assemblies, and if I open those wheel assemblies up, we have, of course, a front and a rear wheel assembly there as it's set in that hierarchy. And that's important to note. Traditional workflows using something like maybe FBX or whatever it may be are not going to support those hierarchies. They're not going to bring over that scene organization. Well, Datasmith does take care of that for you. It brings that over. Now let's get to work here. What is it that we want to do? We've brought this in and we want to be able to start working with materials. Well, in Unreal Engine, it's actually very easy to start to work with materials. In my content browser down below, I'm simply going to right click. I'm going to build a new folder in here and I'm going to call this materials. Now I don't need to do that. I don't need to create a brand new folder in here, but I like to keep it organized. That's what the content browser is for. All of your data lives in here. You can see that I have over here on the left, this is if you don't see this in your Unreal, it's just simply because I've expanded this little sources panel here. You can see that I have this little tree. It's essentially its own hierarchy of content. And that's exactly what we're seeing right here, but it's listed as a stack or for that matter a tree rather than these kind of thumbnails or folder views in here. I like to have both open because I may work between both, taking something from one folder and placing in the other for that matter. Now we've created that materials folder. There it is. It also lives right there. And of course it's empty. Now I like to keep things organized, so that's why I created that. Now I'm going to right click again and I'm simply going to go, I can click up here and create a material, or I could go to materials and texture and hit material there. Same actual icon on here. I'm just going to go material. And just to show really quickly how this works, I'm going to call this one frame. I'm working with a simple little frame material in here. And what I want to do now is apply it to the frame. Well, I'm going to double click on that material. And this is where we look at things and we go, oh, okay, well, what's happening with this in here? This is where we are getting into simply working with the colors that we want to work with. I'm just going to apply in here a simple base color. I don't want to get too complex in these materials right now because I'm showing you just the real bare bones simplicity of this in here. I'm just putting a constant down, and all a constant is simply a 0 to 1. I'm keeping this very simple in here, and you'll see in a moment why, because we're going to dive into something a little more advanced in there. So I can see that I'm actually piping something in here called base color and something in here called metallic. Now if I wanted my frame to be this very shiny uber metallic type of thing, this is where I begin to work with a value in here, and I'd also tie in things like maybe specularity or roughness if need be. I'm going to keep it at that for a moment because we're actually going to come back and look at some more complex networks here, but for the interest of time I'm just hitting apply. We always hit apply on everything we do in Unreal Engine. I just hit save on that one. And I'll just come out of here and let's grab our material. And we have a couple of ways that we can start assigning these materials. Unreal Engine works in this way that it's drag and drop, but it's also by working directly with the parameters. And what I mean by that is I can take this material, left mouse click, and hold it over top of that frame and drag and drop it on there. I could let go of that right now, or I'll just go back to this. I could click on the frame, and we can see over here on the right, underneath our outliner, World Outliner here, you can see that I have the frame, the main frame component selected under that frame hierarchy there. I'm just going underneath the details and we'll see that we have materials. And this is where I could now even do something like this. I could drag and drop that material on there, or for that matter, I could even select the material and even hit this little arrow and that would assign it. So we have a bunch of different ways that we can assign and work with things in Unreal Engine. It's important to note that some people have their favorite way to work and other people may work in a different way. But in this case, I'm just going to take this material, drag and drop it right on top of that frame. Pretty simple, and you can see now that we actually have a nice simple little material applied to our frame. Now, that frame is quite matte. We might want to work with something different there, and we're going to do that momentarily. We're actually going to get into something a little bit more advanced there. So let's actually do that right now. Now, there's how we simply created a real basic material. We just right-click material, added in something to give us a simple color value. We could get really advanced with that. Well, how advanced? Let's take a look. I have in here something called automotive materials. Now, on that note, I want to show you where I've got that from here. I'm going to go to the marketplace, and if you just click on that, we can go to a search tool here, and I'm just going to type in automotive and do a quick search on that. You'll see that automotive materials is actually going to come up. Now, this is free. It's actually built by Unreal Engine. I'd recommend if you want to learn about materials or play with some really nice automotive materials or product design materials for anything. They're not just for automotive. You can actually learn a lot about complex material hookups in there. But I also want to point out if I wanted to get into something like maybe materials, I can go underneath the categories in here and I could find anything related to anything, whether it's materials as you can see right here, but you can also see that we have other things. There's all different types of assets, models, full environments, there's effects, there's even music or sound effects, whatever it may be. But here, of course, we have different materials. Some materials that are free and some materials that you can purchase, and you can bring them right into your scenes. So I just wanted to show that automotive material that I'm working with in there. So let's go back to our scene because I want to use some of those automotive materials. I'm in my automotive materials. I'll just make these folders a little bit big. I'm going to go to view options, just drag that size up a little bit just so we can see it a little bit better. And I want to work with this frame here a little bit more. Now we created a material, but I want to put something a little more advanced on it. And with the interest of time, just to keep things quick, I'm going to use one of these existing materials. Now there's a lot of very cool materials that we have in here. I'm actually going to grab this car paint black. I'll just left mouse click that, drag and drop it right onto the frame. And as you can see, I'll bring that right onto the forks here as well. Wherever I drag and drop that, we can see that we start to get this beautiful paint here. The nice thing about these materials is that we're getting everything from like even that nice little fleck that you might get inside car paint. We can take advantage of that and we can customize these. I can double click on any of these and bring up much like what we saw in the material editor there before. This is actually run from this master material here, and here you can see we were working with simply this little node here as a material. This is why I didn't want to get into too much complexity. It looks daunting at first, but it all makes sense. It's a matter of actually hooking up a matter of number of nodes and networks, and you can get as complex as you want to get, right down to things including things like fleck within the paint, as we can see in this simple little example in here. You can see that we get into this nice sparkling effect. We have full control over this. The material editor in Unreal Engine is by far the most powerful material creation tool or material editor for real-time interactive engines, and Unreal Engine certainly takes advantage of that. So we've put some basic material on there. That's great. Let's dive out to these materials here just really quickly and grab some more materials. Let's go to rubber. There's actually some nice little rubber materials in here. I'm going to just hit escape in the viewport so I have nothing selected. I'm going to grab this MI rubber. I'll put this on this tire, and of course I'll just drag and drop and put it on that tire there as well. So I've just really quickly placed some simple materials on there. Now I know I'm moving quite quickly on this. By all means, if we wanted to get into more advanced materials or more in-depth material networking, that's a whole other discussion. That would be more of a tutorial or even maybe a specific webinar on that. Right now I want to give that nice overview, that quick overview as to how we can work. Here I'm actually seeing a little component, a little piece that's missing something. I'm just going to select that, frame in on that with F, and maybe what we'll do is let's put a little plastic, maybe this coated plastic. So I'm going to select that coated plastic and just drive that arrow onto that so that we're just not missing anything out of there. And I'm just going to click the frame and hit F just to kind of frame that up. Now, a couple of things that we can do while we're working in here. I'm going to hit escape so I have nothing selected in here. And now what I want to do is I might want to be able to start to work with lights. Well, I do have a directional light in the scene. We can see here if I click that on and off, it's the one providing my shadow on there. And we can also see that we also have some real simple basic ambient lighting going on here. And even without the directional light, everything looks quite nice. We don't have any shadows going on, but we have a nice ambient light. And that's simply coming from things like this skylight that we're working with in here. So I'll leave that alone for right now, but there's our directional light. And the way that I actually created that, I'll create one really quickly here. I'm just going to go to the left. I'm going to go to the Lights tab, and we have 4 basic lights, which is great. These are the 4 basic lights that you would use in any kind of interactive environment, a 3D content creation environment, or even for that matter in the real world, like on a film set. Now, they may be called different names, but the basics here are that we can take something like a directional light, which works solely on rotational values, and if I place that into my scene, I'm just going to hit G so that I can make sure that I'm seeing that light, and I'll hit E so I can rotate it. What we're now seeing is that a directional light only works in the direction that I work with it here. So I can start to move that around. It's not going to have any effect on it because it's essentially almost, think of it as a never-ending light, something like the sun for that matter for us on Earth here, is that it is this omnidirectional light that keeps going here forever, and it'll cast rays of light into the direction that we rotate that light into it now. Now, the basics of this, without going too deep once again, are that we have over on the detail panel, we have things like a light color. Let's make that something like maybe a bit of a purple or red, whatever it may be. We can change the color on there very easily to get in there to have an overall impact on that. Of course, we can work with the overall angle of it, but most importantly on here we have the light color, and we have something called intensity. And of course, if I bring that down, that's going to bring that light intensity in that scene. But if I bring it up, of course, it's going to drive the overall intensity of that. Now, there's many different parameters or attributes, just like we talked about the materials. No need to go in too deep. What I'm going to do here is just bring this back down, delete our directional light here, and just work with the existing one that I have in our scene. So with this directional light, I just put in a simple directional light in here. You can see that I also am using something called a post-process volume. All this does is it focuses all the attention of what I'm doing with any kind of viewport effects, my lighting, anything that I'm working with specifically. It kind of hones in on the bike here in that area. I'm going to hit the G hotkey, and all that's going to do is get rid of some of these little gadgets out of the way so that I'm just working with everything live in viewport, for that matter, a clean viewport. Now, if I wanted to add any other lights, I simply can do exactly what I did with that directional light. A point light is simply just a point in space that just is omnidirectional as light. I can drag that in. We have a traditional spotlight, and of course a skylight, which is providing that overall ambient kind of global overall illumination for our scene. I don't have time to go in depth on the lights, but these are the basics of, throwing on simple materials, working with some lighting so that we can begin to visualize this. Now, one other thing that I wanted to show here quickly, you'll see that I'm able to tumble around and kind of interact with the overall scene. At any time, I can hit things, perhaps like the F11 hotkey, to bring it up to a full screen so I can start to see my overall visualization, as it were. I can select something like this overall crank area here and just zoom in to see how it's looking. And at any time, I'll just hit escape on there, I could come up here and click this little down arrow and go to high resolution screenshot. I can scale this or multiply it, and I can actually go ahead and get really high resolution screenshots that aren't just stuck to the resolution that I'm working with. In this case here, I'm just working with simply 1080p, but I'm actually on something that supports fully 4K display. So I could crank that to that or beyond that. We can do really high-res screenshots live out of Unreal Engine. So I'm going to move on here. I'm just going to hit cancel on that autosave and just get back into where we were. Now, we looked at how we can simply bring in our, we brought in our CAD data, how we've added some materials and some simple lights. We can also do some things like set some bookmarks for our cameras in here. Now, I've done that. They're actually mapped to these hotkeys 1, 2, 3, 4, 5. So at any time when I'm working away in my scene, if I wanted to, I can jump between all of these cameras just by simply hitting those hotkeys. And this allows me to frame up things for my presentation in here. Now, of course, there's much more that we can do. You can see up from the play menu that we have here, we have the ability to, we could build an interactive application in here. We could walk around a bike. We could even build a VR application in here and simply be able to build something that we can interact with in VR. Unreal Engine really is completely unlimited in the way that you can experience data. Now, we've taken a look really briefly at the Unreal Engine. Most importantly, we looked at this implementation of the CAD data. We have our beautiful Rizoma bike in here. I can't spend too much time getting into, the in-depth in materials or lighting or into our overall light mask settings. Actually, that may be something that might be worthwhile showing. We can go into our world settings here. We can actually take a look at how that might work. I'm not going to hit build on this, but we can see that we have lighting quality set to preview. I can set this up to even a much more higher quality lighting, and it would need to bake that out. And in the process of baking this, it's actually going to show, or for that matter, build for us resolution of light maps that it's going to store all this lighting data in there. Now, that would be for another discussion where we get more in depth into our rendering, or for that matter, how we actually get and produce the overall visualization here. But these are the basics here. Materials, lighting, very easy to simply start interacting with our scenes here. Now, I'm going to jump back over here quickly to my slide presentation. Here we go. And I just want to continue forward here and summarize here some of our CAD visualization options in here. Now, in the world of CAD, we're typically limited to things like CAD viewport renders. Perhaps it's built-in rendering, or we're working with things like third-party renderers. Now, this is where we're in our CAD package and we want to build some nice visualization. We are quite limited, or we need to leave the CAD package and go into something totally separate where we need to set up things like a V-Ray renderer, Corona, or whatever it may be in a package like 3ds Max or Maya, whatever it may be that we're working with. We may be able to take advantage of rendering in those third-party applications like Cinema 4D or Max or Maya, whatever it may be as well. With Unreal Engine now, with Datasmith, this allows you to take your CAD data and essentially use Unreal Engine as an extension to that CAD data to allow you to experience those designs, to get that real-time interactivity. Now, CAD visualization limitations typically that we've seen up until this point, we're looking at typical constraints like still imagery, working with simple animations like turntables, perhaps it's camera moves. We looked at why Unreal Engine for visualization. Well, really simply, we have the ability to take advantage of interactive, real-time design experiences, and that's the key, right? Images are, they do something. A picture's worth 1,000 words, and that's great. Video, of course, we can create, but to be able to actually experience, interact with your designs, whether it's tumbling around or walking around the design, or an immersive experience like augmented or virtual reality, there's also this ability to gamify your design, and that is produce a game where people can explode it or turn things around and interact with it. We can build fully interactive applications to showcase the design. And of course, as I mentioned, this gamification of design and visualization, the idea being that we can actually create this into something that is playable, or maybe there's a little bit of an entertainment function to the design on there. Of course, this ability to take CAD into virtual or augmented reality. And as well, we have the ability from Unreal Engine to deploy this to unlimited platforms, namely things like desktop or perhaps mobile. So the limitations from the traditional data export for Unreal, and this is without Datasmith, which we now have, is that we are limited to the ability to not be able to work with scene hierarchies or scene organization. We lose any layers we may have created. We lose certain light data and IES profiles if we're working with those, and we don't have any broad or complex materials that are going to translate or come over into Unreal Engine. Not necessarily yet. With Datasmith, we are working on that. And we typically will lose third-party plugin data when we're working with traditional export using other file formats like FBX, for example. And if you're using instances, they're gone. Datasmith aims to solve all of these problems here. So for importing data considerations the traditional way, I mentioned FBX there, it can typically be quite slow and the files can be quite large. And we'll lose any kind of organizational structure via that FBX translator. Datasmith preserves that organizational structure. And we don't need to hop into other packages as much anymore. We can now support that directly into Unreal Engine. Materials are always something that need to be reconsidered. Now, In my example, I was taking advantage of the powerful material editor, the materials and lighting that exists within Unreal Engine. The cool thing about this is now that we have the ability to take advantage of pre-existing materials and lighting that may be set up in other packages. More on that in a moment here. So fixes and adjustments can be very time consuming and result in large files. So that can get into a bit of a time consuming thing, taking away of some of that efficiency in bringing in data into Unreal Engine. And of course, the risk of the loss of positional data and components with traditional workflows. So to summarize this, Unreal and Datasmith, we have a couple points here. Overall, frictionless workflows for visualization artists. We have accuracy, this ability to experience designs anywhere, whether it's targeting mobile or augmented or virtual reality platforms, or this ability to ramp up quickly and get instant results. We can save hours, even days. We've had people on the beta forums talk about how we've saved them weeks. And that's not just time, it's also sanity, but it's also a lot of money that we've saved them. So in the end here, what we're aiming to do is conquering the complexity for engineers and designers. So Datasmith with Unreal Engine really solves a lot of this world of translating data from CAD into Unreal Engine for visualization. So some things here about Datasmith workflows, just some basics on what you need to know. We can take an entire scene and we can convert it with high fidelity directly into Unreal Engine. We can support things like most of 3ds Max's materials and lights, and now recently we're expanding into things like V-Ray, where we're able to expand into the support for V-Ray lights, V-Ray setups, and this is important that people will often take CAD data and utilize the power of V-Ray to visualize for images or perhaps video. They might spend the time setting that up, but now they may want to go into an interactive environment where they can build an interactive application, perhaps some sort of game type of situation or a virtual reality situation. They can take advantage of that V-Ray setup and bring that over into Unreal Engine via Datasmith. We have lots more coming on that as well. Datasmith will take care of this idea of making sure that everything has UVs applied to it. Remember I mentioned light maps or the system of light mass in Unreal. That's a pain point there for CAD. Often we'll get things into an interactive environment such as Unreal and we'll find that, we don't have UVs on everything, and it'll result in things like artifacts. Well, Datasmith aims to fix that for you by putting a very decent layout of automatically generating UVs to take care of that. We also have the ability to auto-convert things. For now, right now, we're working with the ability to auto-convert unsupported image formats. So before, a big error list saying doesn't support that image, doesn't support that format, or whatever it may be, Datasmith will recognize this ahead of time and convert them into something that is Unreal Engine friendly. So you don't even need to see what's happening there. It translates that perfectly over for you. It also takes things like bump maps and translate them into normal maps. Normal maps typically are what we use within Unreal Engine for that higher fidelity that we want for that displacement or that distortion of a surface, or that to the camera, the displacement of a surface based off of the surface normal. And we can do that by automatically or having Datasmith automatically convert things like bump maps into normal maps in Unreal Engine. And of course, I mentioned hierarchies and Scene Explorer supported over into Unreal Engine. So a traditional workflow for design and data optimization, much like what we talked about at the beginning. We're taking things from, maybe it's SolidWorks or Rhino, whatever it may be. We need to bring it into something like Max or Maya, merge those objects, reduce polygon count, define the LEDs, lay out the textures, clean up the data, whatever it may be. Maybe we're translating via FBX, and we bring that into Unreal Engine. We now have the ability to add in Python support. So Python is now part of Datasmith, and it's part of Unreal Engine. This ability to define how that data comes into Unreal Engine, this is uber powerful. In our early stages of this, we had this ability to import CAD data, but all of a sudden you are now sitting there importing everything. Perhaps you need to filter through that data. Maybe there are objects that need to be merged. Maybe you need to reduce the poly count on certain objects. Maybe you need to reduce the poly count on everything. Perhaps you need to define those LEDs. Maybe there are components that you do not want to import. Simple Python script will take care of that for you, where we can define that at the time of import. So Datasmith will define what it is we want to bring in, how we want it to how we want to bring it into Unreal Engine. So the addition of Python to Datasmith really opens up the world of the power of the efficiency of Datasmith for bringing CAD data into the powerful interactive environment of Unreal Engine. I want to say thank you for attending our webinar today. I hope you learned something. The overall point of this was looking at how we're working with CAD data and how we're utilizing our plugin Datasmith and how it exists in those two flavors as we've seen, living inside a 3D content creation app like 3ds Max. But the cool thing now is this ability to take advantage of Datasmith by importing CAD data directly into Unreal Engine, where we can begin to start to work with the power of Unreal Engine. I hope you enjoyed the webinar. Thank you for attending.